Hello everyone, welcome to our first lesson in Math 10, and today we'll just be doing a general review of all the things we did in Math 9. Right, so of course this doesn't cover everything, but most of the important things we'll be covering here. Okay, so starting with place values, so all numbers have place values. Right, the most common one that we use is probably the ones in the tens digit. Right? This is for things like number of students in a class, your age, all that kind of stuff. Right? So let me just move this up a bit so I can have more space here. Right? And as we go to the left, of course, we add more zeros. Right? So after the tens digit, we have the hundreds digit. After that, the thousands. And then the 10,000s. And then the 100,000s. Okay, luckily place values do not change names as you go up a grade. This will always be the names. Hopefully forever. Hopefully you don't have to change it around anytime soon. Right, of course, separating everything here, we call it a decimal. Right, because sometimes we have numbers inside numbers. So between 2 and 3, we got things like 2.1, 2.2. Right, and to separate the ones digit, like the whole numbers, with the decimals, we put a decimal in the middle. And in the opposite direction, right, we just put th behind each place value name. So the tens become the tenth. And notice here that we do not have the ones. Right, we start on the 10th. So after that we have the hundreds. I don't even know if my mic will be picking up my sound. Thousands. It's kind of fun to say. Okay, 10,000s. It's like a walkie-talkie. 10,000s. 100,000s. We're just adding a th behind everything, and then millions. Right, millions. Okay, just again, quick reminder on what the place values are called. I will be referring to all of those. That's a lie. I will probably mostly be referring to the ones in the middle here. I really don't think there'll be any super big numbers we'll be covering. Okay, so now let's put all those numbers on number line. Okay, so starting with 2.5, right? 0.5 of something just means half of something. Right, so 2.5 means that it is somewhere in between the 2 and the 3. Right, and we know a 5 is in the middle of 10, which means that 2.5 is in the middle of 2 and 3. Right, and of course that goes the same for negative as well. Negative 2.5 is somewhere between negative 2 and negative 3. Okay, how about 4 over 5? Right, so with 4 over 5, right, we can think of it as a pie divided into 5 parts. Right, and then 4 of those parts are filled out. Right, which means that it is between 0 and 1. And it's almost 1, but not quite. But it's more than half. Okay, so 4 over 5 is somewhere around here-ish. Right, so it's a bit more than half, but not quite 1. Okay, how about 6 and 4 over 5? Right, so we got 6 whole pies and 4 over 5, 4 over 5th of a pie. Right, so it'll be between 6 and 7. Right, it'll be somewhere right here, ish. Again, this is just a really rough estimate. Okay, how about repeated decimals? Right, with repeated decimals, right, the number just goes on forever. So 213, 213, 213, and so on. Right, so this pattern repeats. So we can pretty much think of it as around 7.2-ish, right? So negative 7.2 is between negative 7 and negative 8. So it's somewhere, say, right here. Alright, somewhere right here-ish. Alright, so keep in mind, the bars determine what numbers are repeating. So for example, if we do something like this, if the bar's only above the 2, 1, 3, then it will just be something like this. Okay, so be careful of what numbers the bar is over. Okay, cool. Next is bed mass. Oh, we love bed mass. Okay, so with bed mass, right, remember, this is the order of operations. We always do brackets first, followed by exponents, followed by division and multiplication. And lastly, addition subtraction. Right, so be very careful here. Right, if we have both division and multiplication, right, we always go left to right. Right, if they're at the same, like quote unquote, if they're the same tier, right, we always go left to right. So division, multiplication, get left to right. Addition and subtraction, go left to right. The reason why we say BEDMAS is because it sounds nicer. Right, it probably sounds nicer than, I don't know, BEMDAS or BEMSA? Yeah, I don't know. It's division, multiplication, addition, subtraction. Just do left to right. Okay, so 3 to the power 4. Alright, that's a simple, it's just an exponent. So there's no BEDMAS here. Right, so 3 to the power 4 is 3 multiplied by itself 4 times, which is 81. Alright, please be careful here. Very common mistake. 3 to the power 4 is not 3 times 4. Right, just be careful here. And as another reminder, the dot means to multiply. Same as this X sign. Right, I use the dot because I'm lazy. Speaking of lazy, we can get even lazier. Sometimes when we have multiplication, so negative 3 to power of 2. If we have brackets, we don't even have to write the multiplication sign. Right? Negative 3 was the 2 brackets, just means to multiply. So if you see a dot, if you see an X, or if you just no signs add up between 2 brackets, that means we are multiplying. Okay, anyways, negative 3 times negative 3. Make sure it's positive 9. Right? 2 negative numbers makes a positive number. Okay, how about this? Negative 2 over 3 divided by 1 over 7. Okay, so multiplying. Alright, this is multiplying fractions, or dividing fractions. To do that, we multiply the flipped version of the fraction. Okay, so we flip it around and we multiply as normal. When we multiply fractions, we do numerator times numerator, denominator times denominator. 2 times 7 is 14, 3 times 1 is 3. Don't forget a negative sign. Right, because it's negative divided by positive. Okay, so we are pretty much done here. Right, as an extra practice, we can convert that into mixed numbers. Right, to do that, we do long division. Right, 14 divided by 3. 3 going to 14 4 times was 12. We subtract that, we get a remainder of 2. So 4 is the whole number. We have 4. We have 2 as a remainder, so it's 2 over 3. Right? Also works, mixed number. Generally, it's in lower grades, we need to convert to mixed numbers. And this is a way for you to keep practicing on long division. But in higher levels, especially in university, you will always see improper fractions. Because at the end of the day, mixed fraction is actually more work, because we got to convert it back into improper fraction to do more math with it. So generally, it's acceptable to just leave it as improper fraction. Okay, how about this? So now we have negative 4 squared. But be careful here, there's no brackets here. Which means that this negative sign does not get exponentialized. This negative sign is not under the influence of the exponent. There should be a verb for that. Exponentialized. Oh, that sounds good. But anyways, right, so it's 4 times 4, right? 4 squared. And notice here that it's not negative 4 times negative 4, it's negative 4 times 4. Negative 16. Because we can think of this as, alright, think of this as negative 1 times 4 squared. That's essentially what's happening. So now we're doing bed math, right? We do the negative 4, or 4 squared, which is 16, and then negative 1 times 16 is negative 16. Right, so the reason why we do it like this is because we're just doing bed math. Here's the curveball. How do we subtract fractions? Right, we convert a whole number into fractions. 3 converted into fractions, and with a denominator of 3, right, we just multiply this by 3 over 3. Then because we want to make sure that the denominator is 3. And of course, we cannot just multiply a denominator for funsies, right? We have to make sure that it is equal. So, we multiply numerator of 3 and denominator of 3. Which gets us 9 over 3, minus 3 over 3, 7 over 3. Right, again, that's the improper fraction. Convert it into mixed fractions is 2 and 1 over 3. That's still good practice though. Right? 7 divided by 3. 3 goes there 2 times, was just 6, was a remainder of 1. Oh, there we go, this bad math stuff. Okay, please do not do addition first. Every time you mess up bed math, the puppy dies. Okay, multiplication comes first. So when we multiply, we can save some steps and reduce ahead. We notice here we have a 2 numerator, 2 denominator. We can actually cancel those 2 out, right, into 1s, right? Because they're both divisible by 2. You can only do this with denominators and numerators. Okay, so we have 3 over 4 plus 1 times 1 over 1 times 3, 1 over 3. Okay, adding fractions, common denominator. The least common denominator is 12. So we multiply both by 4. Which is 13 over 12. Mixed fraction, 1 and 1 over 12. Alright, our first unit, or because this is our first unit, second unit will work more with finding the least common multiple, that kind of stuff. Okay, next. Polynomials. Right, so let's simplify the following. We have 2x times x minus 5. So we need to use the distributive property. I call them flying arrows. So this first term has to be multiplied into every single term inside. Okay, so it's 2x times x. And then plus 2x times negative 5. Okay, so it gets multiplied to everything inside. 2x times x with our exponent laws. X times x is x squared. 2x times 5 is negative 10x. Okay, adding polynomials. We combine like terms. Whoops. X squared. We have the x squared and plus 3x squared. We got a singular minus x and a plus 5x. We got a plus 3 and a minus 1. Right, let's combine them. X squared plus 3x squared is 4x squared. Alright, mathematicians are lazy. If you do not see any numbers in front of a variable, just assume it's a 1. Because we don't want to write it all the time. Okay, minus x plus 5x, so it's minus 1 plus 5, which is positive 4x. Alright, when we are adding and subtracting, right, make sure that the variable does not change, right? X remains an x. Only the number in front of it, the coefficient, changes. 3 minus 1 plus 2. Nice and easy. Okay. Oh, I shouldn't be skipping steps here. Let me actually write it all out. Alright, so the x squared, 3x squared. We're just rearranging it. Right, rearranging it so that the like terms, aka the terms with the same variables, line up. Just like that. Okay, sick. Next, Uh-oh, careful here. We got a minus sign. We're subtracting the fractions. Or, not the polynomials. Okay, flying arrows still apply. Alright, so be very careful here. We're subtracting by a bracket. Remember what's BEDMAS? Right, we do brackets first, and then we multiply. So this, right, we have to flip the signs. Right, the reason why we flip the signs is because we can think of this as -1 times 2x and -1 times plus 5. Right, so we have, right, plus a -1 times 2x, and then plus -1 times a positive 5. Okay, so that's why we flip the signs. -1 times 2x is minus 2x. Alright, so as we can see here, the signs got flipped because we're multiplying everything by -1. Combine like terms, we got an x here and a constant. 2x minus 14. Okay. Last one. How about divided by polynomials? Here's our numerator, here's our denominator. Right, because it's subtraction, we can actually split it up. 12x squared over 4x minus 8x over 4x. Okay, then let's start reducing. 4 and a 12 can be reduced to 1 and 3. X squared divided by x is the same thing as the exponents 2 minus 1, right? So 3x. 8 and 2, or 8 and 4 divided by, oh my god. 8 and 4 reduced to 2 and 1. The x then cancels out. Right, because x divided by x is just 1. So 2 times 1, which is just 2. Okay, that's dividing polynomials. Okay, solving for variables. Okay, first one. Right, we want to isolate the variable. Right, so we want a to be by itself. Let's say a wants to stick it to the left. So we have to somehow squish the 4 on the other side. To do that, we do inverse operations. This is a positive 4. So we can just subtract both sides by 4. To get 10 minus 4 on the other side, which is 6. Of course, this is not completely isolated yet. Right, I have to divide both sides by -1. Because we want the variable to be by itself, there's no negatives. Okay, so it's -6. Okay, next one. Oh, that looks weird. Right, we do not like fractions. We want to get rid of them. So, to get rid of fractions, right, we can multiply everything by the lowest common multiple, or the lowest common denominator. In this case, it's x. Right? If we multiply everything by x, right, then those two will cancel out, and there's no more fractions. Mathematicians, we don't like fractions. Okay, so -2x equals to 3. Yeah, because I multiply -2 by x, so it's -2x. Multiply 3 over x by x cancels out to get just regular 3. Divide both sides by -2. -3 over 2, or -1.5 in mixed fraction. Okay, how about here? Right, lowest common denominator. 5 and 3. Lowest common denominator is 15, so we multiply everything by 15. So this multiplied by 15, that gets reduced to 1 and 3. So 3b equals to, this gets reduced to 1 and 5. 4 times 5 is 20. So this b looks like a 6 here. Right, divide both sides by 3. 20 over 3, which is 6 and 2 over 3. Okay, last one. Once again, do not like fractions. Let's get rid of them. Multiply everything by 2 to get rid of fractions. 3x times 2 is 6x. 1 times 2 is 2. Right, and then those two cancel out. Okay, oh no! We got variable on both sides. So, we have to squish them together. we can move the x onto this side. So we add x here to get 7x equals to 7. Okay. And from here, you can divide both sides by 7 to get x equals to 1. Which is not correct. Hold on a second. Aha! That's my bad. Oh gosh. That's a common mistake that people make all the time. As you can see right there, I actually did not realize that. So, what did I do wrong here? Alright. When I did this step right here, right, I completely forgot about this negative sign over here. Right, because when we cancel those out, right, this x plus 5 should still be in its brackets. Right, because this is essentially saying 3x equals to 1 minus x plus 5 divided by 2. Right, because both of those terms are above the 2. Right, we know that fraction means to divide. Right, both of those is inside a bracket. Right, we just don't write it because it's a fraction. Right, so when I multiply everything by 2, right, the bracket still stays. Okay, and then from there, right, we flip the signs inside, so this goes minus x and minus 5. Okay, then we scooch the x around again. 7x equals to negative 3. Divide both sides by 7. X is negative 3 over 7. Okay, there we go. Right, the real reason why I realized something was wrong was because our original answer was x equals to 1. So we can actually plug it into here. Alright, 3 times 1 equals to 1 minus 1 plus 5 divided by 2. Alright, I'm just plugging x into the question. So 1 minus 1 plus 5 over 2, which is 3 equals to 1 minus 6 divided by 2, which is 3 equals to 1 minus 3, which is not correct, right? So that means that there's something wrong there. Okay, looks. Last one. Similar triangles. So similar triangles. Right. There's always 2 steps in similar triangles. We want to find the scale factor, and then we can find the missing side length. Alright, so we have our 2 triangles here. Shows me those are right angles. I just was not good at drawing them. So the first small triangle has a 4 and a 3 here. Second triangle has 7 and an x, had a hypotenuse. And we know they are similar, right? Because those 2 triangles were made from the same bigger triangle, so they have to be similar. Okay? So now, in order to find a scale, right, we know the scale already, right? To go from 3 to the 7 on this side. But we want to figure out what's the length on this side, so that we can use a scale to compare to what the x is. Okay, so to find out what the length of this side is, we use the Pythagorean theorem, not the hypotenuse theorem. Right, a squared plus b squared is c squared. Right, the side length squared added up equals to the hypotenuse squared. Alright, so 4 squared plus 3 squared is c squared. 16 plus 9 is c squared. 25 is c squared. To find what c is, we just square root of 25 to get 5. Right, so c is 5. Okay, and then from there, we just compare the sides. Alright, so this side to this side, I go over a fraction, is same as this side to this side because they're similar. So 3 over 7 is the same thing as 5 over x, right? Because they're similar. This over this is equal to this over this. Okay, and from here, we just solve for x. Alright, so there are two ways to go about this. We can multiply by the lowest denominator, which is 7x, or I like to do cross multiplication. I call the cross multiplication butterfly. Alright, we can cross multiply to get 3 times x, which is 3x, 5 times 7, which is 35. Divide both sides by 3. Should have left more space here. Whoopsie. So x is 35 over 3. Okay, and then we're done. Okay, so again, this works because they're similar triangles, right? So the proportions, this side over this side, should be the same as this side over this side. Okay, similar triangles. Okay, surprisingly, we will actually still use similar triangles in grade 10, right? But we'll work with mostly trigonometry, which we'll talk about later on. But again, if you're not quite familiar with any of the things that we just talked about, don't worry about it. It's been a while since we did Math 9, right? So yeah, some of you, it's been a summer for some of you, and it's been a semester and a summer for some of you as well. Right? So yeah, don't worry too much about it if you don't remember too much. Right? All we have to do is do some practice and get back to and then get used to it again. So, with that being said, good luck practicing.